This is the second video for chapter 13 on integration. So in this video we're going to look at the next two sections, which is 13.3, which is finding functions, and 13.4, which is definite integrals. So in the first video we looked at the process of integration. If you remember, we said that if we're given the gradient function dy dx or f dash of x, we can take it back to the original by integrating. We looked at the process of integrating, which was getting every term into the form kx to the power n or ax to the power n, and then adding 1 to the power and dividing by the new power, so reversing differentiation. We also talked about why we put plus c on. Remember, plus c is our constant. If you differentiate a constant, it becomes 0, so therefore when you integrate you have to put the constant back. And remember, if you have a constant, then you have a family of curves or a general solution, and if you can find out the value for c, then you have a particular solution. And that's what we're going to look at, how we find that value for c. So the first example, we'll look at that one. We've got find an expression for y in terms of x, given that dy dx equals 2x plus 3 and y equals 5 when x equals 1. So the first thing we're going to do is going to write down dy dx equals 2x plus 3. So there's our gradient function. So to get it back to y, we're going to integrate. So when we integrate, remember, we add 1 to the power, so you get 2x squared divided by 2, which was the new power, and then plus 3x, and then we would add our constant plus c. Okay, we're just going to simplify that slightly. 2x squared divided by 2 is x squared, plus 3x plus c. And that, therefore, is what we refer to as the general solution. And in video number 1, we talked about a family of curves. And the general solution gives us a family of curves because, of course, plus c is where we cross the y-axis. And in this case, we don't know where we're crossing the y-axis, so that's a set of curves. Now we can use the fact that we know that y equals 5 when x is 1, so we can substitute those values in to find out what c is. So y is 5, we're going to substitute x equals 1 in, so we get 1 squared plus 3 times 1 plus c, 5 equals 1 plus 3 plus c, and you can see that c must equal 1. Therefore, y equals x squared plus 3x plus 1. And that is our particular solution. That means that we know now where this family of curves cuts the y-axis, so that's our particular solution. So we've homed in on one of the family. So we've found out what the value of c is. Again, you could be given your question in function notation. Remember, f dash of x is Lagrange notation. So we're given our gradient function. We're also told that when x is 4, the value of y, or the value of the function, is 8. And again, this tells me when x equals 4, so when x equals 4, the value of f of x is 8. Okay, so f of 4 equals 8, so I can replace f of x by 8. So the first thing we're going to do is write f dash of x in a form that we can integrate, and remember the square root of x is x to the power half, so 3 times the square root of x is 3x to the power half, and then minus 4x can be integrated as it stands. So therefore f of x equals, So we're going to add 1 to the power and divide by the new power. So it's 3x to the 3 over 2 divided by 3 over 2 minus 4x squared over 2 plus c. Don't forget the constant. You can refer to him as Colin if you want. Let's just simplify that before we substitute any values in. So you can see 3 divided by 3 over 2 is just 2, as we did before in video 1. And then 4x squared divided by 2 is 2x squared plus c. Now we're going to put in what we know. We know when x is 4, the value of f of x is 8. So 8 equals 2 times 4 to the 3 over 2 minus 2 4 squared plus c. Okay, and then we can work that out. So 8 equals, remember the power 3 over 2 means the square root of something cubed. So 4 square rooted is 2, 2 cubed is 8, times 2 is 16, and minus 4 squared is 16, times by 2 is 32, so it's minus 32 plus c. And if we work that out, we get that c is 24. And then we can put that back, so you can see f of x equals 2x to the power 3 over 2 minus 2x squared plus 24. So again, you can see that this halfway up is the general solution, and this is the particular solution, given those bits of information. There is one other thing that we could possibly do, and that's write the first term in the particular solution in surd form. So f of x equals 2 times the square root of x cubed minus 2x squared plus 24. Depending on the question, you might have to rewrite that index in surd form. We'll look at the next question, and again, let's do a little bit of highlighting this time so we know what we're doing. So we're told the gradient function is, let's do y dx equals 3x minus 1 times x plus 3, and the curve passes through the point 1, 12. We want to find the equation of the curve. So you can see you've given your gradient function, let's do y dx, it's Leibniz notation, so we're going to go back to y. Usually, if we're given something in function notation, we stay in function notation. Given it in Cartesian Leibniz form, we go for Cartesian. So the first thing we're going to do, if you look, we've got dy dx equals, and it's 3x minus 1 times x plus 3. So we're going to have to multiply it out. We're going to have to expand it. So that will give me 3x squared, and then plus 8x minus 3. So we're going to integrate it. And this time I'm going to skip the step, the intermediate step. So 3x squared will become 3x to the power 3 over 3. So that's just going to be x cubed. And then plus 8x squared over 2 will give you 4x squared. And then minus 3 becomes minus 3x. And then, of course, we need to put plus c. Then we put in our boundary conditions. These are referred to as boundary conditions. We're going to put, so y is 12, and we get 1 cubed plus 4 times 1 squared minus 3 times 1 plus c. So 12 equals 1 plus 4 minus 3 plus c. So you can see quite clearly that c is 10, and therefore the equation of the curve is y equals x cubed plus 4x squared minus 3x plus 10. And that is our final answer. Now, on your worksheet, you can see that you've now got some questions. So I suggest what you do is stop the video and do those questions. We're now going to look at section 13.4, which is titled Definite Integrals. And if you notice in the first video, we were dealing with indefinite integrals. Now the difference, I'll just make it very, very clear. The difference is, and I'll write it up here in red. If you just have an integral sign and we're integrating x squared with respect to x, that's what's referred to as an indefinite integral. That's an indefinite integral. And you notice that on the integral sign, there are no numbers. A definite integral, the only difference is we have what's called limits, and it could be two numbers. Usually the top limit is bigger than the bottom, but I do say usually because there are situations where that is not the case, especially when we get to upper six and we apply some techniques. But usually the top limit is bigger than the bottom limit. And in the next video, we'll discuss what these limits actually are. But indefinite integrals are just an integration where you've got limits on the integral sign. So this is a definite integral. This is definite. And there is something very special about definite integrals, and it's to do with the constant of integration. You don't actually need it, but we'll discuss again why that is. So the definite integral is defined as, so this is the integral here between the limits of a and b of f dash of x, which of course is our gradient function with respect to x, equals, and then we go into square brackets. Square brackets are recognised across the mathematical community as meaning that you have integrated but not applied the limits. So we use square brackets to say that the thing inside the square brackets is what we've got when we've integrated. And of course, if you integrate f dash of x, you get f of x, and you put the limits on the right hand side, top limit to the top, bottom limit to the bottom, and then you substitute the top limit in to the function of x, you substitute the bottom limit in to the function of x, and you subtract those two values. I'm going to show that in this example here. So we integrate between the two limits, working out the value at the upper limit and subtracting the value at the lower limit. You can see we're doing the integral between the limits of 1 and 3 of 3x squared minus 6x with respect to x. So this is our integrand, that's what we are integrating. You can see inside the square brackets, when you integrate 3x squared, you get x cubed. When you integrate 6x, you get 3x squared, and of course there's a subtraction between the two, so put that down. It's in square brackets, and you put the limits on the right hand side. Then you substitute 3 in. So wherever you see the letter x, you're going to put 3 in, of course. So 3 cubed is 27, then it's minus, and then 3 times 3 squared is also 27. Then you substitute the lower limit in, so 1 cubed is 1, 3 times 1 squared is 3. Then you work out the value of the first bracket, which of course is 0. You work out the value of the second bracket, which is negative 2, and you subtract those two. So 0 minus negative 2 is 2. And that is the value of this integral. So you sometimes ask to evaluate the integral. So let's have a look at some of these questions. So we're going to start with the first one. So we're asked to integrate between the limits of 1 and 2 of 4x. Now, straight away, it's in the right form. It's in the form ax to the power n or kx to the power n. So we're going for our square brackets. When you integrate 4x, remember, add 1 to the power, so it becomes power 2 or squared, divide by the new power. So 4x squared divided by 2 is just 2x squared. And that's between the limits of 1 and 2. We then are going to put in the top limit. And this is where we go to a set of curved brackets. So 2 times 2 to the power 2 minus, and then we put the bottom limit in, 2 times 1 squared. We work out the value of each of those brackets. The first bracket gives us 8, the second bracket gives us 2. So the value of the integral between 1 and 2 of 4x with respect to x is 6. Now, you can actually check this answer on your class quiz by using the integral button on your class quiz. It's right at the top of the calculator underneath the menu button, and you can type in with your calculator this question and it will give you a value of 6. Now you might say, can I do that in the exam? The answer is no. You can use it to check, but this is what Mr. Examiner is looking for. They're looking for the fact that you've integrated, so they're looking for what's in the square brackets. They're looking for the fact that you've applied the top limit and the bottom limit. You've subtracted those two answers and you've got your final answer, and that is what they are looking for. So although you can use your calculator to check, you cannot use your calculator to cheat. If we look at question 2, you can see we want the integral between -2 and 1 of x squared multiplied by 3 minus 4x with respect to x. So the first thing we're going to do, I'm not going to integrate straight away. I'm going to make the expand the thing I want to integrate so I can integrate it. So x squared times 3 is 3x squared. X squared times -4. Negative 4x is minus 4x cubed, and we are integrating that all with respect to x. Now I can integrate, so I go into my square brackets. I integrate 3x squared, is going to give me 3x to the power 3 over 3, which is x cubed, minus 4x cubed will become 4x to the power 4 over 4, which is x to the power 4, between the limits of -2 and 1. Top limit goes in, so I've got 1 cubed minus 1 to the power 4, minus. Now be careful, you're substituting in a negative, so there are loads of negatives flying about. So it's -2 cubed minus -2 to the power 4. The first bracket gives you 0. The second bracket is going to give you -24, and therefore the answer to that one is 24. So it's very important. Again, you can pop that in your calculator to check the answer. We're looking at number 3 again. The first thing I'm going to have to do is simplify the function I am integrating, because that is not in the form ax to the power n. It's going to give us 2 terms. First thing I'm going to do again is I'm going to simplify that. So I'm going to write it in a couple of stages. This is 2x squared plus 3 over x to the half dx. Now again, when you get good at this, or quick, you can probably do these and miss out a few steps, but there are key steps that you must write down. So 2x squared divided by x to the half is 2x to the 3 over 2, or 1.5, plus, and then it's 3x to the minus a half, and we're integrating that with respect to x. I can now integrate, so I'm going into square brackets. Okay, so this one I'm going to do in 2 steps. So if I add 1 to 3 over 2, I get 5 over 2 divided by 5 over 2, plus that's 3x. And if you add 1 to -1/2, you get 1/2 divided by 1/2. And it's between the limits of 1 and 4. So what we're going to do now is we're just going to simplify that. So remember, when you're dividing by a fraction, it's the same as multiplying by its reciprocal. So this is going to give us 4 over 5x 5/2 plus 6x to the power of half, and that's between the limits of 1 and 4. We're now going to put in our values, and this is where your calculator really does help. First value goes in, so this is 4/5 times 4 to the power of 5/2 plus 6 times 4 to the power of half, minus, then we're going to put 1 in, our bottom limit, 1 to the 5/2 plus 6 times 1 to the half. We're going to use our calculator to help work that out. The first bracket gives us 188/5. The second bracket gives us gives us 34/5, giving us a final answer of 154/5. Okay, and again, you can pop that in your calculator, you type the original question in, it will give you 154/5. And the last one, question 4, again, be careful, both the limits are negative. The first thing I'm going to do, so we are integrating between -3 and -2, and it's x to the -2 with respect to x. Square bracket, remember, add 1 to the power and divide by the new power, so you get -x to the -1 between the limits of -3 and -2. Now be very careful, you've got negatives flying about all over the place. Negative, top limit goes in, -2 to the -1, and then it's minus, and it's minus -3 to the -1, and be careful with this, and that ends up being, so you get half minus a third, and a half minus a third is a sixth. So the value of that integral is a sixth. Now we're now going to look at a problem, just to finish off, look at a problem solving example. So I'm going to get my highlighting pen out and highlight key pieces of information. So straight away, given that p is a constant, and we're told that the integral between the limits of 1 and 5 of 2px plus 7 with respect to x equals 4p squared. We're asked to show that there are two possible values for p and find these values. And that indicates there are two things that we need to do. So the first thing that we're going to do is we're going to write out the integral of 1 to 5 of 2px plus 7 with respect to x equals 4p squared. So we're going to left hand side do what we normally do. So the function we're integrating is in the right form, so we're going to go into a square bracket, and if we integrate 2px to the add 1 to the power and divide by the new power, we're going to get px squared. Remember, this is power 1, so you get power 2 divided by 2, and the two 2's cancel, and 7 becomes 7x, and that's between the limits of 1 and 5, and we know that equals 4p squared. Top limit goes in, so 5 squared is 25, so we get 25p plus 35. That's what I get when I put my top limit in. And then I'm putting my bottom limit in, so that's going to be p plus 7, and we know that equals 4p squared. Let's just sort that out. So 25p minus p is 24p, and then 35 minus 7 is plus 28, and that equals 4p squared. And that looks like a quadratic to me, so what I'm going to do now is rearrange it so it all equals 0. So we get 4p squared minus 24p minus 28 equals 0. Now, it does say I can now solve that, and that will answer the second part of the question, find these values. But it says show that there are two possible values. So in order to do that, I've got a quadratic. How do we show that a quadratic has two values, we use the discriminant. So I'm going to use b squared minus 4ac, where a is 4, b is negative 24, and c is negative 28. Therefore, if I do b squared minus 4ac, that will equal negative 24 squared minus 4 times negative 28, and that equals 1024. And you can say, as b squared minus 4ac, as b squared minus 4ac is greater than 0, therefore two values of p, which is what we were asked to show that there are two possible values for p, and then we're just going to use our calculator, and I'm going to jump back up here, and we're going to pop that in our calculator. You can divide it all by 2 if you want to, or by 4, but your calculator will cope with that, and if you solve that, you get that p equals 7, or p equals -1. And that is that question. So be very careful. Look back at the question. It said, show that there are two possible values for p. Right? Solving it is not sufficient. We show that means you've got to show the intermediate steps. Now, what you now need to do is, in order to practice definite integrals, you can do exercise 13c. There's a challenge on the workbook at the end of the first section, and exercise 13d. And that is the end of video